A universal operating system and a cross-platform operating system are similar concepts but have distinct differences. A universal OS is designed to be a single unified operating system that runs on all types of devices, from phones and tablets to laptops and smart appliances. A cross-platform OS isn't a single OS, but rather software or a development framework that allows applications to be built and run on multiple different operating systems. Fuchsia OS, developed by Google, is an example of a project that embodies the principles of a universal operating system. Universal operating system. A universal operating system, OS, is a hypothetical or conceptual OS designed to run on any device, regardless of the underlying hardware architecture. The goal is to provide a single, consistent user experience across different form factors, from tiny embedded systems to powerful servers. This approach differs from the traditional model where specific operating systems are tailored for distinct device types, such as Android for mobile and Windows for desktops. Key characteristics of a universal OS. Unified kernel. It uses a single core kernel that can scale up or down to support various device classes. Modular architecture. The OS is built with a modular design where components can be added or removed as needed for different devices. This allows for a small footprint on resource-constrained devices and a full-featured experience on larger ones. Consistent user experience. The user interface UI and user experience UX are designed to adapt and scale to different screen sizes and input methods. Simplified development. Developers can write a single application that works on all supported devices, reducing development time and effort. Cross-platform operating system or cross-platform software. The term cross-platform operating system is a bit of a misnomer, as an OS itself isn't cross-platform. Instead, the concept refers to cross-platform software or development frameworks. These tools enable developers to write a single codebase for an application that can be compiled or run on multiple different operating systems, e.g., Windows, Mac OS, Android, iOS. Key characteristics of cross-platform software. Single codebase. The application's core logic is written once and shared across all platforms. Abstraction layer. The framework uses an abstraction layer to translate the single codebase into platform-specific instructions or user interface elements. Wider audience. Applications can be deployed to a broader range of users without the need to develop separate native versions for each OS. Examples. Popular cross-platform development frameworks include Flutter, React Native, and Xamarin. These frameworks help developers build apps that can be deployed on both Android and iOS from a single project. Universal versus cross-platform. Think of it like this. A universal OS is a single magical platform that can adapt to fit any device. A cross-platform framework is a single tool that lets you build things that can be used on different, existing platforms. One is a new, unified platform. The other is a method for building for existing, fragmented platforms. Fuchsia OS. Fuchsia OS is a modern, open-source operating system developed by Google. Unlike Android and Chrome OS, which are built on the Linux kernel, Fuchsia is based on a new microkernel called Zircon. This fundamental difference is a key part of Google's long-term vision for the OS. Core principles and goals. Security and privacy. Fuchsia's microkernel architecture enhances security by reducing the amount of code running in the kernel, minimizing potential vulnerabilities. It uses a capability-based security model, which is more granular than the permission-based system in Android. Modularity. The OS is highly modular, with components or services that can be updated independently of each other. This makes the system more maintainable, secure, and easier to customize for different devices. Scalability. Fuchsia is designed to run on a vast range of devices, from low-power smart home devices to high-performance laptops and desktops. This is the universal aspect of Fuchsia. Updatability. Its component-based design allows for seamless over-the-air updates without needing to reboot the entire system. Fuchsia proofing. Fuchsia is built to address the evolving needs of modern computing, including the rise of IoT, Internet of Things devices. Key architectural components. Zircon microkernel. At the heart of Fuchsia is Zircon, a small, efficient microkernel. It handles only the most essential tasks, such as process management and memory allocation, while delegating other functions to user space services. Fuchsia's UI and applications. The user interface and applications are primarily built using Flutter, a cross-platform UI toolkit also developed by Google. This allows for a consistent, high-performance UI across various devices and makes it easy for developers to create cross-platform applications that run on both Fuchsia and other operating systems. Component-based system. Fuchsia uses a component model where all software, including the UI and applications, runs in user space as a collection of independent sandboxed components. This architecture promotes stability and security. Fuchsia's current state is an ongoing project, but it has already been deployed on some commercial products, most notably the Google Nest Hub smart displays. Its development represents Google's long-term ambition to create a single, secure, and adaptable operating system for the future of connected devices.